Hi all, thanks for watching this video. Welcome to Big Data Hadoop Developer Certification Program, Hadoop demonstration from development perspective. Today we are going to discuss very thoroughly what is dataset, what is big data, and the definition data from IBM side using some of the V's. And what are the challenges that we have with our big data using our existing computational techniques. So when I say existing computational techniques, it can be Java, .NET or any ETL related tools. And what is a Hadoop, then how we are going to deal with big data related issues using Hadoop, and some of the features of Hadoop so that we can know why we have to use Hadoop when you have Hadoop kind of technologies in the market, and the power of using parallel processing. Why we are going to discuss this one, because our Hadoop is going to work based on the parallel processing. Then what is Hadoop cluster and its a co-component. Okay, so then first and foremost thing, what is dataset? Dataset is nothing but collection of related information. We will be calling that one as a data set. Or what is big data? Big data is nothing but collection of large data sets. If you're putting together, that time we will be calling that one as a big data. That is the first and foremost definition that we can give to big data. Or big data is a data set which is impractical to store or impractical to process with the existing computational techniques. That time the data set will be called as a big data. It is not impossible, it is impractical, which means by the time to store the data or to process the stored data, you are getting lot of data. We are not able to manage your data using our existing computational techniques. That time we can call that one as a big data. This existing computational techniques or existing techniques, whatever we have, they are straining to process the data behind the storage capacity, behind the processing capacity. That's what the data is getting into the warehouse. That is the reason they are not able to create the report on time. Okay, so what is the definition of big data using some of the V's from our IBM sides? That's what we are going to see in our next slide. So here you can see very clearly volume, velocity, variety and veracity. So these are the 4 V's. Using these 4 V's, IBM has defined the big data. Okay, let's go ahead and see one by one. What is volume of data, what is velocity of data, what is variety of data, and what is veracity of data. So this, let me take the simple example. Just take the example of Amazon.com. As you know, whenever you go and access the Amazon.com, obviously they are going to capture the customer's activity and they are going to put it somewhere in the access log or somewhere else. So that has to be captured somewhere, stored in somewhere else in the warehouse. So you can see here the amount of data that you are trying to write from your source to Amazon.com to your destination or warehouse. Okay, that time we will be calling as a volume of data. So for example, I am storing 100 GB of data from my source to destination. So this is volume of data. Okay, and then what is velocity? Velocity is nothing but, okay, you are trying to store 100 GB of data from source to your warehouse at what speed? Which means this 100 GB of data you are adding to the warehouse in a week, in a month, or in a day, or in a month. So that is at what speed we are trying to add so and so data from source to destination. We will be calling as a velocity. Then what is variety? Okay, the variety is nothing but we are trying to add or store the 100 GB of data from source to destination within a given period of time, probably within one day. But what type of data that you are trying to add? It can be text files or video files or audio files or JSON files, whatever it is. So as you know, the data can be divided into broadly in three parts: structured data, which is having some, we have organized your data in a rows and columns, that is called structured one, and semi-structured, which is nothing but you just given the meaning to a data only halfway. The best example XML or JSON formats. And unstructured data, there is no structure, we did not organize the data, so there is no starting and ending position of the data. That time we will be calling as a unstructured data. Okay, that is variety of data. The last one here is veracity of data. Okay, so what I mean by veracity of data here is, we are trying to store 100 GB of data from Amazon.com to my warehouse, but out of this 100 GB of data, what data will be useful for my data analytics? Am I going to use entire 100 GB of data? No. Probably for my data analytics, I might be using only some portion of data, probably 10 GB of data in this example. Okay, so to extract this valid data, I mean remaining 90 GB of data is not valid for me in this case, in this data analytics. So this 10 GB of data is only the valid data for me in this case. So this 10 GB of data, extracting the required data for your further analytics out of your raw data, that time we will be calling as a veracity of your data. So now, if your data set is having these characteristics: high in volume, high in velocity, high in variety, and high in veracity, that time we will be calling the data set as a big data. This is the purely, the definition is given by the IPM. Very important thing. Okay, so yeah, so we are having this many characteristics, or we are saying this is what the data is getting added to the warehouse, but from where the data is getting added into your warehouse. So right side you can see the picture very clearly. Within 60 seconds of time, how much data we are trying to add to our warehouse. So you can take the simple example from the YouTube. 600 plus new videos are getting added to the warehouse within 60 seconds, which means within 1 minute of time this many new videos are getting added into the YouTube warehouse, and this many new domains are getting registered in our digital world. 70 plus new domains are getting registered, and you can see how many new blocks are getting registered within 1 minute of time, and you can see how many emails has been sent, how many searches are happening only from Google, and you can see how many images are getting uploaded into Flickr, and how many voice calls are happening over the Skype within 1 minute of time. So this clearly talks about 4 V's. Okay, which means the volume of data. You can see high volume of data you are trying to add to the warehouse. The velocity, within 60 seconds of time this much data you are trying to add, which is huge actually. The variety, which means the structured, the semi-structured, unstructured data also it is there. The mostly you are going to see the unstructured data out of these all sources, and the veracity. So as you know, whatever you are getting into the warehouse, that does not mean that everything is going to be the useful for our data analytic purpose. We have to extract the portion of data, we have to continue with our data analytics part. That is the reason we will be calling that one as a veracity. So this picture clearly shows these 4 V's involved in our big data. Okay, then the next is the what are the challenges. Yeah, we are getting the data from last 25 years, but all of a sudden why we have to talk about this data? I mean, the best example, our RDBMS is going to handle, or is already is ruling the data from last 25 years, but why we have to talk about this data? Because this much of data we are getting from the different sources, this existing computational techniques. You can take RDBMS, or you can take Java or .NET or mainframe related systems. They are training to store or to process the data. Somehow we are able to manage to store the data by having by attaching the more than one computer to the system, only limited computers again, but we are not able to process the data. As you know, even though you are storing your data in a multiple computers while storing your data, but at the time of processing your data, you have to pull your all data together, then only you can process the data. Okay, so this is the biggest issue that we have currently with our big data. That is the reason our existing computational techniques are straining behind the storage capacity, behind the processing capacity. That is the reason we are not able to come up with the report on time, or we are not able to take the business decisions on time based on the data that we have available in our warehouse. Okay, these are the challenges that we have using our existing algorithms currently. Then what is Hadoop? Okay, Hadoop is a open source framework which is written completely in Java on Linux platform, which is intended to resolve the big data related issues in terms of storage wise, in terms of processing wise. The main intention of Hadoop is to address these issues out of our big data. So why we have to use Hadoop when you have Hadoop kind of technologies in the market? The first and foremost thing here is Hadoop can collect the data from different sources. It can collect the data from logs, it can collect the data from sensor data, it can collect the data from satellite, or it can collect the data from different servers, mail servers, system servers. So easily it can collect the data from the different sources. That is the main features of Hadoop, and it can do its best for the batch analytics, and also it can do the real-time analytics, which means like batch analytics is something like it can collect the data over a period of time. On top of that, overnight you can run some of the programs to see your data analytics or to create the report out of that. Or real time means whenever someone is sending the request on top of your big data, it can process and it can serve the request back in a real time also. So Hadoop can do batch analytics as well as the real-time analytics, and also Hadoop is going to do its best the predictive analytics, which means based on the data that we have available in our warehouse, we can predict the business, or we can predict the customer behavior, or we can address the customer complaint easily. So using our Hadoop we can do that one also. And one of the best feature is Hadoop can store the raw data in a commodity hardware. So what I mean by commodity hardware here is it's a cheap hardware, which means it's a low reliable hardware. So we don't have to spend lot of money to buy these commodity hardwares. So exactly, if you take any language that we are running in the production, if you want to store your data or if you want to make it as a server, obviously we have to go with the enterprise hardwares, because they are high reliable hardwares. You have to make sure they should be always up and running in order to do some activities in your production grade environment. So but your Hadoop can store the data in a commodity hardware, which is the excellent feature out of our Hadoop. Then how we are going to overcome, how we are going to address when you are going to use the commodity hardwares, low reliable hardware, cheap hardwares, whatever we are using in our personal computers, they are the low reliable hardwares. Okay, so we are going to see that how we are going to address this issue. And the next thing is it can store the raw data or process data directly in the DB. Before you are storing the data into your warehouse, you can process the data, or you can directly store the data that you are getting from your different sources. And a visualization also can be done. You can create the different dashboards using our Hadoop. And the next thing is the scalability. This is the one more best feature is available out of our Hadoop framework. The scalable means you can scale your system, how many computers that you want, how much storage capacity that you want, you can go ahead and add. How much processing capacity that you want, you can go ahead and add to the system. That is called scalability. There is no limit to scale your system. You can, there is a infinitely, you can just go ahead and add the number of computers to the system. And the next one is fault tolerant. So what I mean by fault tolerant here is, as you know, when you are going to use a commodity hardwares, there will be always the system may go down. That's what we are saying. Commodity hardwares means low reliable hardware. They may go down anytime. Then how we are going to address that issue? Using this fault tolerant techniques only, we are going to address this one. Using these techniques, our Hadoop framework is going to recover the data automatically if any one of the commodity hardware is going down. Okay, our Hadoop framework is going to take care of that. Okay, the next thing here is power of parallel processing. So what I mean by power of parallel processing here is, I mean, why we have to discuss about parallel processing here is, our complete Hadoop framework is going to follow this parallel processing method only. So that is the reason we had to discuss about the parallel processing. Let's go ahead and discuss one by one. What is this parallel processing? What is the advantage that we are going to get out of this parallel processing? Let's go ahead and see with the simple example. Okay, so here I'm going to give simple example here so that it will be giving the a good idea about how this parallel processing is going to work. For example here, okay, let me pull my paint. Okay, so here, for example, my boss is here and I'm here. Okay, so this example is going to cover a lot of concepts that we are going to discuss about out of our Hadoop framework. That is the reason this is very important thing. So now, as you know, my boss is here and I am here. Okay, so myself here. So he is trying to assign some work for me. Okay, he is going to assign some work for me, saying that, okay, he is going to hand over the 10 physical papers for me. These papers are having, physical papers are having the temperature recorded over a period of time. Okay, so and he is asking from the different cities the temperature has recorded over a period of time, and he is asking me to find out the maximum temperature out of these 10 papers. Okay, maximum temperature out of these 10 papers. So in this case, okay, as you know, as I am alone, what I am going to do, I will go through paper by paper, something 10 papers I will go through. I will find out the maximum temperature out of these 10 papers, and I am going to report the saying that probably 45 degrees and Hyderabad. Okay, and I am going to give the maximum temperature back to my boss, saying that. So to do this task, probably I might have taken 10 minutes of time to come up with the maximum temperature out of this 10 papers. Okay, my boss is okay with the results, but he is not okay with the time that I have taken. Okay, he says that he cannot wait this much of time to do the data analytics, which means he cannot wait this much of time to see these results. He wanted to see the results less than 5 minutes. Okay, boss, I said, boss, I did what I can do maximum. I cannot reduce the time less than this one. But he said, whatever you want, I can do. But he wanted to see the results less than 5 minutes of time. So next, the model that I'm going to follow just here. So again, he's going to give the same work to me. I'm here. And this time what I'm going to do, I'm going to recruit 10 workers under me. Okay, so this time what we are going to do, I'm going to manage them. I'm going to recruit the 10 workers under me. I'm going to manage them. Okay, so now here I'm going to, for them I'm going to work as a manager kind of thing, and I'm going to have the 10 workers under me. Worker 1, worker 2, worker 3, 10 workers I have under me. So now whatever is my boss is going to assign these 10 papers to me, he is going to hand over to me. So here the 10 papers, instead of I'm going to just have the 10 papers, what I'm going to do this time here is I'm going to divide that 10 papers into 10 pieces, which is obviously there. So I'm going to distribute one paper to each guy, one paper here, one paper here, one paper here, which means I have distributed the data across multiple workers now. Okay, only one worker is not going to process my entire data. I have distributed the data. Okay, then whatever task that I got, so he's going to ask me to find out the maximum temperature. The same task I'm going to assign to individual worker. Worker 1, go ahead and process this page, whatever you have paper, find out the maximum temperature out of that paper alone. Then this guy has to go through each paper alone and he has to find out the maximum temperature out of this one. So these individual workers has to care about only their paper. They don't have to worry about other paper what they are doing. So the same way this guy. So the same way this guy. So now 10 workers have started working on this paper. So probably each worker has taken 1 minute of time. Within 1 minute of time they gave the results back saying that okay, this is my maximum temperature. They reported back to me out of this paper alone. The same thing, this guy has taken 1 minute of time and they have reported the status back. And this guy has taken 1 minute of time, reported the status back. And these guys, all 10 workers have taken 1 minute of time to report the status back. So now I have the 10 results with me. Okay, 10 results I have with me. Now my job here is only to aggregate this data. So now I am going to aggregate this data and I am going to find out of this 10 maximum temperature 45 degrees and Hyderabad. Okay, so in this process my each worker has taken 1 minute of time. As you know, all workers have started at the same time, so within 1 minute of time I'm going to see my end results out of my all workers, and plus I'm going to take 1 more minute of time to process this one. So within 2 minutes of time I came up with the maximum temperature out of these 10 papers and I sent back it to my boss. So he was expecting less than 5 minutes, but I gave within 2 minutes of time. This is the power of parallel processing. Okay, the same thing if you just convert into our current big data world. As you know, just think like this 10 papers, think as 10 terabytes of data. So now you got 10 terabytes of data from ABC source and you are trying to store the data using single computer. Just think like this rounds wherever you are seeing these machines, computers. So using one computer you are processing the 10 terabytes of data, which is like it is getting a lot of time. But as you know, here my boss or my stakeholders, my end users, they don't want to wait this much of time to see their end results out of these 10 terabytes of data. Okay, so that is the reason this standalone is failing to do the data analytics on top of the big data. Okay, so we are able to process this data but not on time. It is impractical. Okay, if by the time we process the 10 terabytes of data, it is taking a lot of time. Probably we are not able to address the customer complaints, we are not able to take the business decisions on time, we are not able to introduce the correct products on time. So that is all these things are happening if you are going with the existing computational techniques to deal with your big data. So now to this right side model, whatever we have just discussed, the parallel processing, the 10 terabytes of data we are going to divide into 10 parts. Okay, so we are going to see very thoroughly how and what is the measurement that we are going to take to divide these 10 terabytes of data into 10 pieces. But as of now, 10 terabytes of data will be divided into 10 pieces, and each piece that we are going to store in a individual computers. So now this is one computer and this is one computer, so something like that 11 computers I have put together within the network. So this 11 computer, if you are putting together within the network where they can talk each other, that time we will be calling as a cluster. So within this cluster they can talk each other. This cluster concept is not only unique with our Hadoop, this already exists, so we just utilize that concept here. So now what we did here, we just distributed the data across multiple computers instead of storing in a single machine. So this concept in our Hadoop framework we'll be calling as a distributing the data into multiple computers. So we will be calling this one as a HDFS, Hadoop Distributed File System. This is one of the core component out of our Hadoop framework. Using the HDFS file system only, if we are going to store our data, we are going to distribute our data into multiple computers. Okay, then whatever the task that we got out of our client, finding out the maximum temperature today or tomorrow, finding out the minimum temperature, finding out the average temperature, finding out the different tasks, whatever task that we want, we can go ahead and perform on top of this data, because we distributed the data across multiple computers. Now we can perform whatever tasks that you want. So now finding out the maximum temperature, whatever you wrote the logic to do just on the single machine, the same way we have to write almost to our Hadoop framework also for the parallel processing, and that whatever you wrote for the single machine, the same logic will be sent to this machine and this machine and this machine, and each machine is going to work on top of this 1 terabyte of data, and this guy is going to work on this one, and this worker machine is going to work on this one, and this worker machine is going to work on this one. So the 10 worker machines are going to start working on this, each 1 terabyte of data out of your individual machine. So by doing this one, so individual computers has to take care of only 1 terabyte of data, not 10 terabytes of data out of this one. Even though individual worker is enough capable to process your entire 10 papers, but we did not assign to the single guy, we distributed that work to across multiple workers. The same way here, even your single computer is enough capable to process your 10 terabytes of data, which my Hadoop framework is not going to do. It's going to distribute the data across multiple computers, and it's going to distribute the same task across multiple computers. It is get it done on time. So this is called parallel processing. So the storage part, we are talking about the HDFS. The processing, whenever you wanted to process the distributed data with the help of HDFS file system, that time we will be calling as a MapReduce. Okay, MapReduce is a programming language using which you can process the large data sets with the help of HDFS file system in our Hadoop framework. Okay, so this is the power of parallel processing. So just think like you got the more data from your boss. Just I got 90 more papers, so total 100 papers that I got. So obviously if I am alone, if I want to go through this one, obviously I will take around at least 50 minutes of time to come up with the maximum temperature out of this one. Okay, 50 minutes easily. But the same way, if you are going with this one, as you know, if I want more storage capacity, I just go ahead and add one more worker here. If I want more processing capacity, I will just go ahead and add. So in this case, I'm going to add 90 more workers. Then still within 1 minute of time, I'm going to see my end results out of each and every worker. Probably I might be taking 2 to 3 minutes to consolidate the final results. So within 5 minutes of time, I'm going to see my end results. Okay, so this is the power of parallel processing. Okay, if you want more storage capacity, just go ahead and add one computer. If you want more processing capacity, just go ahead and add one more computer to your cluster. So this entire thing is a cluster. So then what is Hadoop cluster? If you are putting Hadoop machines together within the network where they can talk each other, that time we will be calling as a Hadoop cluster. So where you have installed the Hadoop software in each and every machine, and if you are going to take care of that one, then that will be calling as a Hadoop cluster. Okay, this is all about the parallel processing and its the advantage. Then what are the challenges that we have using our parallel processing? There are some challenges because as you know, you have to divide your entire work into units of work. So who is going to do that for me? Or probably I have 10 workers here, but I have 15 terabytes of data. Okay, so then I have the less workers than my work units. Then how I am going to manage that one? Or sometimes this guy is not working. Okay, this guy is dead. Then how I am going to manage that work? Or this guy is not up to the mark, he is working very slowly. Then how I am going to consolidate my results? Do I need to wait all the way till this guy is done? Or probably I would like to share the results in between. Then how I am going to do this one? So this, for all these issues, concerns, the only solution is Hadoop framework. As a developer, we don't have to write any separate logic to handle this kind of things. Hadoop framework is going to take care of things completely. How we will be writing the logic for our individual computer to process any data that you are stored in that machine? The same way we have to write our programming language in our Hadoop framework also. The rest of the thing is going to taken care by our Hadoop framework. The only answer for all these concerns is Hadoop framework. Okay, so the next concept that we are going to see here is the Hadoop cluster. We have seen the and you can see at the right side here, this is a typical cluster. You have one master. So Hadoop framework is going to work with the master slave architecture, which means master is the one who is going to take care of a thing, and under that I'm going to have the worker nodes. Slave nodes, worker nodes, both are same. So I have 4 worker nodes here, and I have one master node here. So that is the reason we'll be calling this one as a master slave architecture. So Hadoop has 2 major echo components, which we have already discussed. HDFS, Hadoop distributed file system. Using this one only, we are going to distribute our data across multiple computers. Then MapReduce, it's a programming language where we are going to use this technique to process the distributed data across the HDFS file system. Okay, then the next thing here is, these are the Hadoop echo components that we have currently in our market. So as you know, in this picture you can see very clearly HDFS, Hadoop distributed file system, which is the underlying data that will be stored in our HDFS file system. Okay, so means we are going to have a cluster. Within the cluster we will be having more than one computer. The whole data will be divided into chunks of data, and the data will be shared across the multiple computers. Okay, that is called HDFS file system. So Hadoop distributed file system, this is the core component to store our data. Then next, on top of that, we will be seeing the MapReduce. So MapReduce is a programming techniques. As you know, it will be working on top of our HDFS file system. So in order to write our MapReduce program, you can use Java, you can use any programming language, probably C++ or Java or Ruby on Rails or Python or any other programming techniques that you can go ahead and use. But to recommended one is just to go ahead and use the Java for your MapReduce program, because the Hadoop framework is completely written in Java. Then we are going to, when you are going to write your MapReduce programming in Java, it is going to help us to minimize our number of lines to talk to our Hadoop framework actually. So that is the main advantage why we have to go with Java when you are writing the MapReduce program. So obviously, I mean, you can go with the other techniques also, no problem. But in order to write your MapReduce program to work on top of this big data, obviously we need the basic skill set of either Java or your Ruby on Rails or Perl or C++ or Python, whatever it is, but you need the basic skill set of these things. But as you know, in the market, people who are having the Java knowledge are very less, or people who are having the Python knowledge are very less. So that is the reason they just try to ease the writing the complex MapReduce program by introducing the different echo components here. So one of them is Pig and one of them is Hive. Okay, so what is this Pig? Pig is a scripting language. It's very simple. Pig is going to use its own scripting language, that is called Pig Latin scripting language. So what we are going to do here is, instead of writing as a developer, Pig developer, I'm not going to write the MapReduce program in terms of Java. What I'm going to do, I'm going to develop that simple Pig scripting language, probably 3 to 4 lines. If you take the example finding out the maximum temperature, probably if you are going with the MapReduce, you may end up having 30 to 40 lines of code to write your Java. But whereas if you are going with the Pig scripting language, we will end up having just 5 lines. These 5 lines of code will be converted into MapReduce program by our Hadoop framework. So end of the day, these 5 lines will be converted into MapReduce program, and that MapReduce program is going to work on top of my HDFS file system. So end of the day, the process that we are going to do remains the same, but who is going to create the MapReduce program for us? Hadoop framework is going to create the MapReduce program for us. As a Pig developer, all we are going to do, we are going to write the Pig scripting to find out the maximum temperature, but the 4 to 5 lines of script will be converted into MapReduce program by our Hadoop framework. So that is the reason Pig is residing on top of your MapReduce. The same way with Hive. Hive is same as your SQL query language. Okay, so where you can write your queries on top of your data. Those queries again, 3 to 4 lines of queries again will be converted into series of MapReduce programs. Those MapReduce programs are going to work on top of the HDFS file system. Okay, so that is one more thing. And here the right side you can see here HBase. So HBase, Pig and Hive are going to use the MapReduce program. Obviously it's kind of batch oriented. It will take some time to process the data. We may not able to achieve the real time. It's kind of high latency will be always there. But HBase is the one, it's a columnar database. Okay, it's a NoSQL database, which means probably if you take the RDBMS related database, we may able to store the millions of instructions or transactions within the database. But if you want to store the billions of transactions, it is not possible. Billions of transactions are possible because we have seen that data within 60 seconds of time, how much data that we are getting out of your different sources. So obviously whenever you wanted to deal with the billions of instructions, we need HBase kind of database. It's a columnar database. We are going to represent the entire data in a column oriented way, which we are going to see very thoroughly. And here you can see my HBase is going to utilize the or take the advantage of HDFS, but it's not going to take the MapReduce. It's not going to utilize or it's not going to trigger the MapReduce program. So your HBase is going to be is there for the low latency. Okay. And this next thing here is Oozie. Oozie is the workflow, which means you have to, whenever you wanted to do any data analytics on top of any organization, either you have to run one or more than one MapReduce program, one Pig probably, or not more than Hive programs also you have to trigger in order to do your data analytics on top of the data. So you have to run these all programs in a desired pattern. So as you know, whenever you wanted to run A program, then B, C, then D program, something like that, you have to have a lot of manual efforts to keep track of them and run them manually one by one. So this will be always the error proven there. So there will be some mistakes because before running a job, we are going to run B, C, something we are going to see. So to just address that one only, as you know, the schedulers came into the picture. The schedulers are not unique for the Hadoop framework. We have already have schedulers earlier. So here also Oozie is a scheduler workflow language using which you can schedule your jobs in a desired pattern to run in our production grade environment. Based on timings you can trigger, based on the availability of data you can trigger, based on the job that you have completed earlier, you can trigger the next job. This is completely the scheduler, something like the job control M. We have the Oozie also. Okay, the next echo component is the zookeeper. It's a coordination tool completely between the parallel processing, which is our Hadoop framework, and the client. Whenever we send any request to the Hadoop cluster, the first and foremost thing, it will go to the zookeeper. Zookeeper is the one who is going to coordinate whether the system is enough capable to take the request, or it can hold, or which master it has to take care. All this coordination will be taken care by zookeeper. It's very small echo component, but it's very, very powerful. Okay, the next thing is left side, you can see scoop. What I mean by scoop here is, yeah, as we know, our data resides from last 20-25 years in the RDBMS databases. Okay, so probably in a MySQL. So I would like to, using this RDBMS, we are able to store the data, but somehow we cannot process the data on time. Okay, using the techniques, we are not able to do that one. So obviously, what is our next thing? We have to dump this data into our HDFS file system. Then we can apply one of these techniques and we can start processing the data. But to dump the data, to import the data, if you are using any third-party tools, obviously it will take days and days to do just import the terabytes of data or petabytes of data into our HDFS file system. So in order to import the data from your RDBMS related databases into the HDFS file systems, we are going to use one ETL tool from our Hadoop framework site, that is called Scoop. SQL to Hadoop. Scoop means SQL to Hadoop. So as you know, SQL to Hadoop, whatever queries that you wanted to fire, which means whether you wanted to select only portion of data out of your tables, or all tables out of your database, or entire data out of your database, all only the incremental data, which means that newly updated data, whatever you have in that data, you can import the data. The same way, using your Scoop, you can export the data back to HDFS file system also. You can do that one also. So Scoop is the echo component using which you can import and export the data back and forth using your Scoop echo component to your RDBMS related database. So Scoop is mostly 99% it is going to deal with the structured data, because whenever you are going to deal with your RDBMS, the data is already organized. The next one here is Flume. Flume is a same as Scoop, but Flume will be used to collect the data from the large log files, servers. Okay, it's a kind of near real time. So the moment you are going to access your Amazon, you might be adding some data to the access log. I can just go ahead and collect that newly added data based on the capacity or based on the defined batch time. I'm going to collect the data. I'm going to put it back to the HDFS file system. So Flume is one more echo component using which you can collect the data, or you can import the data and put it into HDFS file system. That is one more ETL echo component to just import the data from huge log files then and there into our HDFS file system. Once we keep the data into our HDFS file system, we are going to use one of these Pig or Hive or MapReduce or HBase to process the data to come up with our final reports. So that's all we have out of this Hadoop demonstration. Thanks for watching this video. Thank you.